Welcome to a new lesson on my Learning VBA playlist. I hope you liked lesson 1 and you had no problem completing the exercise. After all, it was same as what we have done during the lesson. This time we will mostly work in a blank Excel document, writing our own code as opposed to recording macros. As usual, link to this example document will be in the video description. Let's get started because there is a lot to learn today. Today I'm going to talk about a few things. The first is going to be variables. And variables are essential part of programming because in any code you would need to store data, and the way to store data is that you create variables where they say that, okay, I'm going to store data in this one, I'm going to name it this, and that's how I'm going to refer it in the code. And whenever we talk about variables, we also have to talk about data types, and that goes really back to the beginning of the computer technology and how information is stored in the computers. But I think especially in Microsoft Excel and the type of programs that you are going to be doing in Microsoft Excel, I think we can, just forget about how it originally started and why some of these data types have developed the way they did, and then just focus on some of the more common ones that you are likely to use in a Visual Basic for Applications program. Again, you're not going to be doing your really hardcore development in any Office programs, so we are just going to focus on the ones that you need to know. And of course, when we talk about data types, unfortunately, we have to talk about conversions because you have to be able to convert between data types. But again, I think we are lucky that we are going to be working in Visual Basic because it really makes our life easier when it comes to different data types and conversions between them. Once we move away from this whole area of variables and storing data, we start going into another programming principle, which is the different methods or the subroutines in Visual Basic. And that shouldn't be entirely new because even on the first program we have dealt with methods or subroutines that are being created by the macro recording, but we are just going to take another look at them, how you can do your own. But this time we are going to take a second look of subroutines, how they actually work and how you can use them, and just explain the basic programming principles, how you can structure your code in methods. And when we talk about methods, again, I'm going to say methods and subroutines interchangeably because I think methods is a more generic programming term and subroutines is how it is called in Visual Basic. So when we talk about subroutines, we also have to talk about functions, which is, let's say, a special type of subroutine, but again, equally important and probably is even more widely used than the simple subroutine itself. So I think that should be the agenda in a nutshell, so let's get started. So here I have a completely blank document. I'm going to press Alt F11 to go into the Visual Basic editor, and because it's completely empty, it's missing the module that we had last time as it was created by the macro recording automatically. So this time we are going to do it ourselves. So I'm just going to highlight these Microsoft Excel objects in the project tree view, and then right click and say insert and then module. So it will create our class 1 module, the same what we have been using in the last lesson. And as I said, we are going to do most of our coding ourselves this time. So with Excel, you always want to do something which starts with a button or something on the screen. And whenever you are creating a UI component, that needs a subroutine that it can call. So obviously the first thing that we are going to create is we are going to create a new sub, and I'm just going to call it lesson 2. And just like before, when we press enter, the editor does most of the the pretty printing for us, which is making the instructions uppercase, and then for the sub it's putting the end sub as well. And what I mentioned also last time is because these are both the sub and the word end are reserved by Visual Basic, they are being shown in blue color. And we got this opening and closing brackets under lesson 2, which again happens all the time. We have seen it last time as well. We don't really know why it happens at the moment, but we are going to get to that later on today. So the first thing is that we have our program and we want to store some data. So again, let's take a really simple example that you want to perform a basic mathematical functions like adding two numbers together and then put that value into a like the result in as also store the result. So for this mathematical calculation, we need basically three variables. We need the two values that we want to add up, and then the sum which gets calculated as a result. So for that, we will need two variables where we are going to store the first value, the second value, and the result as well. So the way to do it in Visual Basic is to use the instruction dim, and then you specify your variable, which can be like variable _1. Let me type it this way. And again, as I said, whenever you do instructions or variable names or subroutine names or whatever, it has to be one single word, so no spaces, underscores are allowed, and you can use uppercase, lowercase as you like. So I'm creating a variable which is called variable1, so I just define it here. So I can do the second one as well, variable2, so it's going to be two different variables. But I'm going to be lazy because I don't like typing too much, so I'm just going to be naming them A and B. But of course you can keep it you can keep it as long as you like, because if you do it longer, that's usually easier to remember what they do rather than remembering that's A and B. And of course, the larger your program gets, it's always better to be more descriptive because it just makes your life easier. As I mentioned in the agenda, when we create variables, we also have to talk about data types, because we just told Visual Basic that we are going to create a variable A and B, but we haven't really specified what type of data that we want to store. Do we want to store text? Do we want to store numbers? What type of numbers? Is it going to be positive numbers, negative numbers, fractions, or what kind of number range? And that's what the data type comes into. That's why the data types are important. So if I just do a simple Google search VBA data types, then I will get some results. Then we can see what are the data types that are supported by Visual Basic, and they are actually here. I have to refer back to myself about 5 minutes ago when I was talking about how information is stored. So you see here in this table that we have data types, and they have like storage, like how they are stored and the values that they can represent. So let's just forget about storage and also notice that there are so many different data types, and the only difference between them is how big number they can store. Like for example, you have an integer which can only store up to 32k, and then you have this long which can go up to like 2 billion, and the single which goes up to a much higher value, and then you have doubles and currencies and decimals. So, and these are only the numeric data types, because then you have some other data types like text data, and then you have dates and objects. And also what I mentioned at the beginning is that we will see a lot of different data types, but I just want you to focus on the few of them so you remember them in the beginning, because these are the ones that you are most likely to use. And let me just go back to the numeric data types. So these are all when we want to store numbers, and unless you want to do like maybe financial calculations when you have to go to a higher value, I think in most cases we are going to use integer, because it's a nice type. It supports negative and positive numbers as well, and then for counting things and doing simple arithmetics, probably 32k is enough. If we don't, then probably we should use long. That's the easy one. And also out of the numeric types, I would also mention double, because that supports fractions as well. So if you need like float numbers where you have decimal places. So again, just remember integer for the time being. And also out of the non-numeric data types, we are going to use strings, which can be any text, and then a Boolean, which is again something that we have seen in lesson 1 as well. Do you remember when we were changing the properties of a font, whether the font should be bold or italic? So they had an attribute which was either true or false. So that's the Boolean type that we have seen and then we started playing around with. Also, we have a date, but dates are a little bit complicated to deal with, so I will save them for a later session. So again, Boolean, string, and integer. That's what we are going to focus on. Sorry, integer. So that's what we are going to focus on today. So let me go back to the Excel document. And as I said, our first example is going to be just simple, adding two numbers together. So all we want to deal with are integer numbers. So to specify the type, after the variable name, I type the word as, and as soon as I press space, I get a long list. And in that long list, if I start typing the type or the data type, then the list automatically goes to those the matching results. And the reason you see this huge list, because you remember in lesson 1 I talked about objects. So when I define a variable, it can be like a simple type, like a number or a Boolean or a string, but a variable can be an object as well. So the reason you see all these items and then actually these funny icons with these 3 color patches are the icon for objects. So all the different objects that exist in Visual Basic, in Excel, these are mostly Excel objects, can be actually defined. So this is why you see so many of them. But again, let's just stick to the agenda for today. Damn it, sorry. So now I've defined my 2 variables, so the 2 numbers that I want to add up, and let me define the third one as well, which is going to store the result. With these 3 lines in the code, all I have told Visual Basic is I need A to be a variable which stores numbers, same as B and C. So I haven't really specified anything, any actual value itself. And to do this, you use simple instructions like A equals 12 and then B equals -2, and then of course C is going to be 10, but you can just use simple mathematical equations like here, like A plus B, and then you can use the basic mathematical operators like plus, minus, and star for multiplication and a slash for division. And of course, if you have multiple variables, then you can use the brackets just like you would use them in any mathematical equations. So we have done a piece of code which adds these 2 numbers together. Okay, nothing complicated just yet. And we can create our first button here, and then we can assign a macro to it. Because we have created it as a subroutine in our code, we can assign that to a macro. So we can assign to lesson 2. I'm just going to rename the button. And if I click on it, then, well, nothing really happens. And the reason I'm saying nothing really happens, because there's nothing really happens on the screen, but in the code we haven't really told Excel to do anything on the screen. All we have just said is that we have 12 and -2, and we want to add them together and put it into C, but C doesn't manifest itself on the screen. So nothing really happens on the screen. We can use what we have learned in lesson 1 and put a breakpoint. And by the way, I also wanted to highlight that I said previously that you can only put breakpoints into certain lines. So because the dim lines here where you declare the variables are not actually program codes, they are only like declarations, you can't put a breakpoint here. So you can put a breakpoint here and then these lines, but well, nowhere else at the moment, not on the dim lines. So maybe I just put right in the beginning where the lesson 2 sub starts. And if I let it go, if I run, then, okay, let me just go to the next line. And if you remember how we use the watch, when you have variables, you can just move the mouse over the variable name, and then you would get a variable name and a value in a hint. So at the moment we have variable a, which is 0 because we haven't assigned any value to it. And if I step through this line, now a is 2, and b is 12, and b is -2, and c is 10, pretty much what we expect. So our code definitely works, but it just doesn't write anything to the screen. And to make this value somehow visible, I'm just going to show you a very simple instruction, which I think we are going to use quite a lot, well, especially I use them quite a lot, which is called the Messagebox, which is short for Messagebox. And so you type that, you press space, and you get this hint here on the screen. And that's similar to the list of, when we pressed space after as, we have seen the list of variable names, or sorry, data types. So in certain cases, Excel knows that, okay, this message box is an instruction. So I'm going to show you the format, how this message box expects the values that it can, use. And as you can see, the first one is already highlighted. And that's actually works pretty much the same as when you are dealing with Excel functions. So if you get used to the things that when you do like I don't know, VLOOKUP, so even here, so VLOOKUP is a valid function in Excel. So when you do the brackets, then it shows you the actual parameters. And that's the exact same concept in Visual Basic as well. So Messagebox is a valid Visual Basic instruction, so you get the list of variables that you can expect. So as the name suggests, Messagebox is going to display some message, and then in the prompt we can specify whatever message that we want to display, and that can be something simple like hello world. If I could type, and then we get hello world. Y is in double quotes. I'm just going to return that to a little bit later, but instead of something like that, we can also specify the name of the variable. So Messagebox C is going to tell us that the value of C is 10. So obviously it doesn't print C, it prints the value of that variable. And obviously that variable needs to exist. So if I'm going to print Messagebox D, then we are not going to get anything back because, well, D doesn't exist, or at least we haven't declared it as a variable. So Excel doesn't know how to print it. And actually in other programming languages, you would get an error message because you have tried to reference something which is not declared. But Visual Basic is a little bit easy on that subject. So you can actually use a variable without declaring it, but I would always suggest to declare it with an actual type, because that's going to make your life much easier later on. So Messagebox C, that's where we were at. So with this really simple example, now you know how you can declare a variable which stores numbers, how you can assign a fixed value to it, well, just basically type the value, and then how you can assign a mathematical equation to it, which is again how you would do it in with paper and pencil. So that would be all about the integer values. Let's just move over to the next one. Maybe the next one should be a string. So a string could be anything which is like any text. So I wanted to say dim s as string, and giving a value to the string works exactly the same way as giving to an integer, but because string can contain special characters and spaces and many other things, you have to tell Excel when the string starts and when the string terminates, and we do this by double quotes. So this is how you put the word hello world into the variable s, which is a string type. And if I messagebox that string out, well, first we have two message boxes now, so we get 10 and then we get hello world. So simple as that. That's how you define a string type of variable and how to assign a value to it. And we have seen how you can do basic mathematical equations in integer values, but you can also do some equations for string values as well. And that's going to be, well, because it's a string, you can't really just add, words together, but you can add them in a way that you can concatenate, string pieces together. So if I change this to say that the value of C is colon, and here I'm not going to use the add command because it's not like a mathematical addition, but if I just use the and sign, so the and letter and C, then let's see what's going to happen. So actually saying the value of C is 10. So again, if you look at the code, so the value of C and the value, so the value of C is 10. And the reason it prints 10, because I haven't put the C in double brackets, so Visual Basic knows that I'm not trying to print the word C, but I'm not trying to print the letter C, but I'm trying to print the value which is in variable C. So if I would put C in double quotes, then let's see what happens. Well, the value of C is C. So okay. So because I've put it in double quotes now, so it treats it as a fixed text. So it just treats it as as the letter C. So obviously, therefore, anything in double quotes is going to be interpreted as a fixed text. Anything which is not in double quotes will be interpreted as a variable name. So the value of that variable is going to be used. And of course, it works exactly the same way here as well. The value of C is 10. So you can use the same kind of function here when you try to specify a value of a variable, but you can use these functions like adding strings together, or you can use even A and B. Ten, okay. So you can use it inside, well, not inside, but within when you are calling a method and you are listing all the parameters. The last data type that I wanted to talk about today is the Boolean, and because B is already used, I'm just going to use the word bool. So dim bool as Boolean, and that's the yes/no type of variable or data type. And if I try to give it a value, because Visual Basic knows that this variable is a Boolean type, it only offers me to assign the value true or false to this variable because, well, it knows it's Boolean. So I can do, true. And I can even use the message box on this data type. And it's just going to print the word true because it's true. As we go along, we get all these message boxes because, well, now we have 3 message boxes, but we are only really doing the testing of the last one. So what if I want to get rid of this message box, but I don't want to do it permanently just for now? And again, that was something that I touched previously, on the previous lesson, is that if you put a single quote into a line, then anything after the single quote is going to be ignored by Visual Basic. So it can be basically any text. So I can use the single quote here to, well, basically leave a comment. So C equals A plus B, and then just a simple single quote, and let's add these numbers. And I can run this program, and obviously Visual Basic will not try to execute this comment. So that's how you leave comments. Wherever, whenever you feel like. If you want to leave multi-line comments, then just make sure that you have the code on first line and the second line as well. And if you comment or if you use the single quote on any valid programming lines, that's basically you're commenting that line out, which means that the program is not going to execute them. It's just going to treat it as a comment line. So if I execute this piece of code now, this first message box and the second message box is not going to be executed. So we should only see one message box, which is going to say true, and that's what's going to happen. What I can do with when I assign the value to this bool value, like I can assign the value of a plus b into the c because it's an integer one, so that sort of makes sense. But a true or false decision can be whether a and b are the same value, and I can actually do the same here. So if I can do like this, the value of bool should be whether a and b are the same value, and I will get false because they are not the same. And in fact, I can use the usual less than greater than signs here as well. So is a greater than b? So that should be true, right? Yeah. I can also use greater than equal. That's going to be true as well. And then similarly, I can use less than equal. And if I use the two greater than smaller than sign, that means does not equal. Then obviously we will get true because 12 does not equal to -2. So this is how you use the three basic types. And of course, as we have seen, there are many different values like longs and integers and doubles and bytes. So if you are doing something where you need financial calculations and you have to go into the millions, then you just change the integer to longs, and well, pretty much everything is going to stay exactly the same way. So if I can add 12 and -2, one being one data type and the other one being the other. Well, technically, this might cause an issue because in long you can specify a value of a couple of millions. You are trying to add or actually subtract another value from it, and the result might not fit into this variable. But if it does, then your program will execute without any issues. But again, let's stick to integers, strings, and booleans for now. So by now we have seen how you can use the basic data types, basic as I mean my basic data types, what I usually use, especially in Visual Basic. As I mentioned in the beginning, in most cases you need to convert between them. One of the easy conversion is when you convert a number type, for example, an integer, to a string so you can show it on the screen. And that's actually already happened here because this message box is going to print like a text value, like a string value, but you are passing something which is a number type value. But as you have seen, nothing really happened. You just say, yeah, just print C and then deal with it. And actually, Visual Basic deals with it. Some other programming languages might not be that forgiving because in some cases you will be forced to first convert this number to an integer. First convert this integer to a string, because then you can only assign it to a function which expects text to be displayed on the screen. But actually Visual Basic can do all this for us. And it doesn't appear to be such a big deal at the moment, but if you would be using more complex type, let's say anything which contains a fraction or anything which contains a really high number, then you actually need to specify that if you want to display like a few hundred millions, do you want to display them in all digits or do you want to display them in scientific format? If your number contains decimal places, how many decimal places you want to see? If it's a currency type, do you want to see, do you want to show the currency value? Do you want the negative sign to be on the front or at the back? So with integers, it's very, very simple and it's very, very straightforward. But for other types conversions, well, another example is a date. Do you want the date to be like in a short format, a long format? Do you want only the date or the time or just the time only? So again, in some cases, conversion really makes sense because you actually want to specify something in a conversion, but in simple types like integers, it's very simple. And also what I wanted to show you is that another piece of automatic conversions happens on this line as well, because here we are assigning a value to a string variable. So we have specified a piece of string, and after that we have we put a value of an integer one. So again, we haven't really done anything here. Visual Basic did it automatically for us, so it sort of works, and it's going to work in, let's say, I would probably say mostly in all cases, but you need to resort back to conversion functions when you want something to be displayed in a specific format. And let me just Google one more, which is the data type conversions in Visual Basic, and you see that there is a lot of conversion function available. They all start with C and then followed by the type that the function converts into. So a cint is going to evaluate anything which you pass into this function and then try to return it as an integer value. And actually I think that's what we are going to be using most, because sometimes you have somewhere on the screen or somewhere else you have a value which is being passed through as a string, like a text file or whatever input program, and you need to actually convert it to a string. Because if you specify, let's say, if you say s equals 12, so this is a string value where you are putting basically the digits 1 and 2, you won't be able to add it together because you can't just add the string 12 and minus 2 and expect 10. So that's when you need a conversion. So you will do it like this again, cint, and then let's see. You see, it expects an expression and then it returns an integer. Actually, I'm running a little bit ahead with this one because we are going to talk about this last part which says as integer a little bit later. But if I do this, let me comment this one out. I don't need that one as well. Well, what now? So if I do this, then we will get 10 back, because the word 12 as in 1 2 can be converted to integer 12 because it just only contains number. If I would add a 12a at the end of it, we get an error message which says type mismatch. And if I click on debug, then we can clearly see that this is a type mismatch. So 12a cannot be converted to a number by Visual Basic, unfortunately. Some programming languages would say that, okay, I can recognize 12 or 1 2 as 12, and then I have an a here, I don't really know what to do with this, so let's just stick with 12. But Visual Basic says that it's a type mismatch. But if I do something like this, like 2 spaces and 12, that would still be converted to 12. So there is a little bit of intelligence in this conversion, saying that leading and trailing spaces would be ignored, and of course if it has minus 12, then that would be interpreted as minus 12. This is why you would need to use conversions, and I think probably later sessions we would use some of these, but if not, then it's just better that you know about this, and then at least you know how to Google for it, and then get some examples how you can convert different data types. So I think that should be all about variables, defining variables, giving values to variables, displaying them, the different data types, and glimpse of conversions in really a nutshell. What I want to do now is delete some of this code that we have written. So just stick to the really simple one. So the three variables A, B, and C, and then the addition, and then displaying the end result in a message box. because what I want to talk about now is I want to talk about the methods or subroutines. So here we have a really simple program which basically adds two numbers together. But let's just assume that this is a rather, a lot more complicated piece of code. Maybe it is a much longer code, but this is some piece of logic that you would need to reuse in your code in multiple places. So it wouldn't be the best if you just copy and paste C equals A plus B, or whatever your code is, into multiple places in your code, because you need to execute that function or that calculation or that function in multiple places. So it would be much nicer if we can just put it into one place and then use it multiple times. And actually that's what methods are for. So we have already created a method which adds these numbers together, but let's assume that it also has some lot more code here. And then addition is only just one part of the function. So we want to move this addition somewhere else. So for that, we can create actually a new sub. So let's say we want to create a new sub, which is called add. And so we can move these two lines of code there. So here in lesson 2, I just specified the two numbers that I want to add, but the function, the sub add, performs the actual addition and displaying the end result. Looks very straightforward, right? So it should work without any problem, right? So let's see how it performs. Oh, of course it doesn't do anything, because we moved the C equals A plus B into this add, but we haven't called this add. So we actually have to say that, so the addition is actually now in the sub add, so we have to call the sub add. And if we click on the button, then it says 0, which is kind of odd because we have 12 and minus 2, so that should be added together, right? And again, the code looks okay, so what could be the problem? So, well, we need to go back to debugging, so let's just put a breakpoint and actually follow this program through. So we have A and B, and we put 12 and minus 2, and we can see that it's 12 and minus 2. And now we go to add, and if I click on the usual button, then we get the result immediately, which we don't really want. So what we actually want is to use this other button, which is here, which is a step into. And so step over executes the line where you have the yellow cursor, but step into goes into any code which is called here. So step over will execute add, but step into will step into that add function. So if I click on that button, we see that it doesn't get executed immediately, but we now jump into the sub add. So we can actually follow this code through. So we reference our function add, and the execution actually continues in the function add. And now we can use our old button, which is a step over, and then do C equals A and B. And we can see that A doesn't have a value. It says A is empty. So it's actually adding two empties together, which, it just becomes 0, and that's why we see the value 0 at the end. But why it doesn't have a value? We just specified that it should be A and B, and then when we move here, it actually shows that it's still 12 and minus 2, but here it shows empty. The reason this is happening, we might already see in the code. So what you see here is we define these variables within lesson 2. So in between the sub and the end sub of lesson 2. So these three variables exist within lesson 2 sub, and they don't exist in the sub add. And that's called the scope of these variables. So what you define in a subroutine only exists in a subroutine. So there must be a way to define something outside the subroutine, right? And actually there is. And if you remember, again, it was something that we briefly looked at, well, briefly seen in lesson 1, is here you have this drop down where you can see all your subroutines, and then there is also this part in declaration, and if you click on it, nothing really happens. The cursor just jumps to the top row, but that's actually the space where you can define stuff which are outside a particular subroutine, but they are, let's say, included in all the subroutines. So anything you define here as in variables will be visible to every single sub in this module. And for that reason, because they are not local to any subroutines, they usually also called global variables, or that's how these type of variables are referred to in other programming languages. So if I run my program now, let me just take out the breakpoint. If I just let it go, now we get our value that we were looking for. Because, actually, no, let me put a breakpoint here. So now if I break here, we can see that the variable a and b are visible in Subadd, and they have the value what we have assigned here in lesson 2. Now we have a subroutine which actually does all the addition, and well, we can use it multiple times. As I said, now we have to want to add different numbers together, and if I execute it, then first we get the result of the first addition and then the next one. So it all works fine. I also have to say that the way this add is declared here and then how it is created here is not any different from this message box. Add is something that we have created ourselves, but Messagebox is something that Microsoft has created for us, so we can use it in Visual Basic or in VBA. And if you remember, when I was typing the value C, I had this value assigned to prompt, but actually there is more stuff here. So if I would press the comma to go to the next variable, sorry, the next parameter in this method, we will see that we can define some buttons and the title and a have file and a context. We don't really know what this is at the moment, but this is how we, put multiple pieces of information when we call a method. So at the moment we haven't passed anything to add. We just told add, just add these numbers together, and of course this code knows that it needs to add A and B together, but it would be nice if it can add any numbers together, because let's say, what if we have a more, a complex program here which also has 2 additional values like dim, E and F, and we also want to add E and F together. If we just do it like this, like E equals 20 and F equals 30, and we call add, it's not going to give us 50 because it can only add A and B together. So it would be nice if we can just somehow tell add what are the 2 numbers that need to be added together. And that's what we can do using the Messagebox example, where we can see how that it is possible to actually put values and then pass values to a method then the method can use. And actually this is why we have the 2 brackets here. So up until now we have seen that we just type the name of the sub and these 2 brackets automatically appear, like opening and closing brackets, and that's actually where we define all our parameters that are going into our methods, and these are called arguments. And the way you define the arguments is almost exactly the same how you define your variables. The only difference is that we don't need to use the verb dim. So here, again, for the add function, we want to pass 2 arguments or 2 variables together. I'm not going to call them A and B again, so I'm just going to call them value 1. And again, we need to use the as because we have to specify the type. So the first one is going to be integer type, and then value 2 is again going to be integer type. Excel does the pretty printing for us. So value 1 as integer, value 2 as integer, and from now on we can use these as variables here in our code. Again, these value 1 and value 2 are only valid within the sub. So instead of saying A and B, we can use value 1 and value 2. And now we have modified how we call the add function. We have to make the same changes here as well. And as soon as I press space on add, we can see the new syntax, which expects value 1 and value 2. So I can do A and B. Sorry, A and B. And here I can do E and F. And if I execute it now, you get 20 and 50. And that's what we expect. Or the sub add is no longer dependent on the code here, because there is no sort of like knowledge shared between the two subs that, well, I expect the values in to be stored in variables A and B, because you are actually passing the values here. So this, now you can write a subroutine with arguments that it doesn't have to know anything about how this is called, because all it cares about is what are the values that are being given to me, and then it can decide how it needs to work with those values. And then one more thing I also want to point out, because this add now calculates the value C, I can actually use the same value here, because as again, just like all my variables at this example right now, they are all defined in the global space. So even though that the sub add modifies this value here in the add sub, I can also see that same value in the lesson 2 sub. So if I see, that's the result of the first addition, that's the next one. And now I'm displaying the value of C, which is 50, and that's the end result of the last addition. So the updating or modifying the global values works both ways. So every subroutine has access to these variables, and every subroutine can modify them the way they want. And that can be a good thing, because that's a really easy way to share information across your entire code. But that could also be problematic, because, for example, if you are only looking at your lesson 2 code here, there is no piece of code of making changes to variable C, but all of a sudden, just by calling A makes changes to C. So if you want to use C for something else, and then you accidentally call the add function, it will make changes to C. So that can be really confusing, and sometimes not desired, well, let's say, side effect. And for that reason, we would like to keep most of our variables local and only use global variables when they are absolutely necessary. And actually, because now I'm only using A, B, and E and F here, so add is no longer using A and B, it's only using value 1 and 2, which is local to him. I can actually move my variables A, B, and E, F back to lesson 2 as local variables. And if I run our code, it will output the exact same thing. So the only thing that we are keeping global is the C, which contains the sum of the two parameters. And actually there is a way to go around this as well. So we can make this adding sub is completely self-sufficient. And that's actually something that I've already shown earlier when we used the cint. Do you remember? Cint. So as the syntax highlights suggest, or this hint suggests, it does something, and so within the syntax highlight it says at the end as integer, because what this cint does, it's like a method which expects one expression as an argument, and actually it also outputs something. In this case it outputs an integer. And also same we have seen here in the message box. So again, this message box does a lot of things, like it accepts a prompt and a button and the title and a help file, and then at the end it outputs something as a VB message box result, which we don't know what it is at the moment. But if we look at how this works, I have this message box which does a prompt. Okay, so that's going to be the text that is getting displayed. And then the next one is what it says. It says buttons. And then you can see that there are a lot of choices here, because by default you get a message box which the title, it says Microsoft Excel, so it shows you the value and it has an OK button. But what if I want a message box which is going to be a question? So instead of one OK button, I want a yes and no button. So I can just specify the buttons as VB yes no, and then the next one is going to be the title. So I can specify my own title instead of seeing Microsoft Excel. And no, I'm not going to talk about the help file and the text, the help file and the context because they are not so straightforward. But if I execute this code now, we got those two standard message boxes from the Subadd, but for the third one, now we get a customized one, which, it still shows 50 because that's the value of C. But now instead having one OK button, it has like a yes and no, and it also has a custom title. And the reason this method has a result, because that's how it's going to give us back whether we have pressed the yes or the no button. We are not going to use this right now. I just wanted to show you the concept of why we would have methods which do something without returning a value. I mean, let's say if you have a method which formats a table, it formats a table and then that job's done. It doesn't really need to return anything. But if you have something else, for example this addition, then obviously there is an end result of that function, and that end result is going to be some sort of value which has to be returned, because it only makes sense that that value is returned to the function that calls that. So actually we don't need this anymore, so let me just comment this out. I want to modify this add sub the same way what I have seen in the message box, that I'm passing value 1 and value 2 as arguments, and somehow I want to be able to pass the result back. And you specify that almost the same as you are doing a variable declaration. So again, you are using the as keyword, and then again you specify the type. And the way you read it, okay, so the way you read it is that you actually specify the add to be an integer type, because it's this sub add which is going to return that integer. And the reason I got an error, because Visual Basic says that sub, you can call something a sub which does not return any value, but as soon as something returns a value, it is not a sub, but it is a function. And if I just change the word from sub to function, and then Visual Basic changes the end sub to add function, all of a sudden now it expects the as integer, or basically the as whatever, at the end of the function name. But again, that's how Visual Basic deals with it, so we have to deal with Visual Basic that way. So now we have specified that our add is actually a function. It expects value 1 and value 2, and the result of that function is going to be the integer. And the way we can assign the value to this function which is going to be returned is that the name of the function becomes a variable as well. Or actually, let me put it this way: you can refer to the name of the function anywhere within the code. So what I say is, instead of put the value 1 and value 2 into C, we put it into add, and that's how we can pass the value back. So now my add function is solely responsible for adding value 1 and value 2 together. And actually I should also remove the message box C here, because when you define a function like this, that function should only be responsible for, making that calculation. Whether you want to display the value of it should be placed in your parent code, in your caller code. And the way you can do it is actually you can do it like this. So C equals add A and B. And again, another piece of thing that is the way Visual Basic handles it is, well, actually the way most programming languages handle it, that when you call a function where you are passing arguments through, then you put the arguments into opening and closing brackets. A sub, you can leave the brackets away, but if you're using a function, then you must have the brackets. So again, it's just the way it works. So now, because it is a function, you have to put the brackets, and of course the end result needs to be assigned to a value. So, and now we can actually, and we should display the value of this addition here in our master sub, which is the lesson 2. And again, the C, now the variable C is only used in lesson 2, so we can actually move our variable back to local variables as well. And if we execute the program now, then we get the result what we expect. So 10 and 50, exactly the way we want it. So now we are basically in full control of specifying 2 variables that needs to be added together, and also processing or displaying the end result here in the lesson 2 subroutine, and the add is only responsible for adding the 2 together. So this add doesn't know where the value 1 and value 2 is coming from. It doesn't care, and also it doesn't care what you are going to do with the end result, whether you are going to store it somewhere or whether you are going to put it into a message box. And of course, just like with anything else, we don't have to use variables to use this add function. So I can do Messagebox add 10, 60, and that's going to work as well. 10 and 70. So you can always nest these functions together. And the reason this works, because the add, you are still passing 2 parameters or 2 arguments. The fact that they are not variables, but they are fixed values, Visual Basic doesn't care about it. The result, this add is going to return something that Messagebox can understand. Well, it's just a value, so Messagebox can display it. So everyone is happy and your code works. So again, I just wanted to show you that putting information into a variable, calling functions or methods with a variable or with fixed values works exactly the same way. Do you remember when I said in lesson 1 that everything we are going to deal with in Excel is mostly going to be objects? Well, actually, all of the functions that you use in Excel can be treated, well, in fact, they are actual functions in Visual Basic as well. I mean, not all of them, but let's take an example. I mean, I don't know if you have used the functions which manipulate text or text kind of data, like the left, right, and the mid one. So if I have, this is my text, you have this left function which only returns the left of a string, first X letters. So left C7 E4, sorry, I'm using semicolon separator, is going to return this. And exactly the same can be used in Visual Basic as well. So let me just reinstate my dim value, sorry, my string value, dim as string. And then Messagebox. Let's say s equals, this is my text. And Messagebox left. The string, that's f, and the length, Well, as you can see, it's long and not integer, but okay, 4. So that should return this. And well, the other message boxes. So again, left is, I mean, it's just like a function. Well, it works exactly the same as the add one. It has 2 arguments. The first one is the s, the other one was the length. Sorry, the string and the length. And again, just like here, we put because it is a function and we are using the return value, we put the parameters or the arguments in brackets, and then whatever comes out of this goes into the message box. But I can also do it like this, left. So I'm passing this, the source text, as a fixed text, and then I'm getting the first 4 characters on the left, putting into variable s, displaying that variable s, and that gives me exactly the same result, which says this. Unfortunately, not all the functions that you remember from Microsoft Excel is going to be used in Visual Basic. I think for text, most of the basic ones like the left, mid, and they work. But there are some others which they may seem like really basic functions, but they are not the same in Visual Basic. So for example, you have the square root function, which is sqrt in Excel, but in fact in Visual Basic there is no sqrt. But if I search in Google, then we can find that in Visual Basic it is actually called that's vb.net, which is not something that we want. I put the wrong one. Okay, so VBA square root. So the VBA Visual Basic function for it is sqrt for some reason. So Microsoft hasn't managed to keep it really consistent in this regard. So if I Messagebox sqr12, then well, we get the same result back. Well, slightly more significant places. Well, time really flies when you are having fun, and this video is already over an hour, so I think I should really wrap it up and then show you the summary and also give you the exercise, which obviously you need to do today as well. So in summary, what we have done today is we looked at the variables. We learned how we can declare variables, how you can what are the basic data types that you can use, and well, what are the data types that I think you are going to use most of the time. So those are the ones that we looked at in particular, and those are the ones that we practiced. We learned how we can assign values to these variables, whether it be fixed values or it can be expressions as well. We also talked about conversions and why we need to convert between different data types. This is not something that we have practiced a lot in this lesson, but I'm pretty sure that it is going to come up in the future as well. So we will have the time to look at conversion again whenever it becomes necessary. When we played around with the variables, we also learned about the scope and what is global and local variable, and when you should use global and local variables. And at the same time, we also learned about how you can modularize your code, how you can move different pieces of the code into different subs, and what is the whole idea behind this. And that actually took us to our next part of the lesson, which was about subs, how you can create subs, how you can define arguments, how you can pass information to the sub, and how you can use them. After we were done with the subs or the subroutines, we learned about functions. Function is, let's say, a specialized type of sub which actually returns a value. Today you will have an exercise as well, and that exercise is going to be fairly similar to the exercise in lesson 1, but obviously we are going to enhance that by whatever we have learned today. And I'm not saying that you should actually use that file and then make modifications of that. You can start from the beginning and then start creating the macro. But again, we would be doing similar things. So we will start with an Excel file which has a table that we want to format, and we want to have different formatting options to be applied by Visual Basic Code. So again, what I would like you to do is that you again move the formatting logic into a separate sub. That it's something that we have done already. I also want you to create a separate sub for the formatting the header of the table and also formatting the content of the table. You can do it by copying the code, or if you're not confident enough that you can properly split the code, you can create a separate recording for header and a separate recording for the content content of the table. And as we have done today, you should move some of the variables in your code into arguments, into the sub header or into the sub call. So like the way we have done it with the range, or whether the font should be bold or italic, or the line weight. So those should all be parameters and part of the sub argument. And of course the code should use those arguments. I also want you to try implementing changing the background color. So again, as something that we looked at in the first lesson, we have seen that there was a part of the code where it changed the background color and the background shading, and then we also mentioned that the background color looked like some sort of ID, like X says something, X and 5. So we still haven't learned how you can define what are the different colors, but you can go around this problem by creating a multiple macro recordings where you change the background color to a few sets of, well, some predefined whatever colors that you want, that you like, and then basically from the macro recording you can copy those color numbers and then use them in the final code. And just like last time, you should create multiple buttons that would apply different formatting. And now you remember, because we are, or you are going to move the header and the content formatting code into different subs, that those buttons would need to call both of them to make sure that both the header and the content are getting changed. So finally, once you have finished this, you should again have a document with a few buttons on the side that would apply different formatting to your main table. Thank you for staying with me till the end. If you think this content was good enough that you would pay for it, I have a good news for you. Click on the Patreon link above and follow the instructions. Otherwise, subscribe and like, because as you know, that really helps. Thanks for watching, and hopefully see you in the next video.